Okay. So we did this last week, right? Um, Again, I'm going to stress to you the when you wire uh, between sensors and your Raspberry Pi, there are pins. Sensor pins needs to be consulted from sensor specifications, or there are um, um, some designated the pin. For example, uh, one pin may be for ground, the other pin may be for power supply, maybe third pin will be a signal, uh, yeah, data signals maybe coming out or going into, maybe multiple of such pins available. So that is the sensor side. And then Raspberry Pi side, there are two specifications. So board circuits are organized in this way. Okay, that is so-called the board. Okay, so as you can see,
Professor,
yes.
DD is waiting for to get into the class.
Okay. Yeah, yeah, right. I noticed that was knocked the door, I think 30 minutes ago. And then when I started this, not there. So yeah, automated. Okay, so make sure that your pin in this orientation, okay? Your SD card plugged here, all right? That is the top. And then on the right side, there's two columns of pins. So left-hand side, the pin numbers in odd number, and then even number on the right side. There's serial numbers there, okay? In addition to that, there's another designated pin numbers that is from the BCM. So for some of the sensors, they have SDA signals, SCA signals, and then SPI, so serial port IO, MSI, MISO, or some of the CLK port, EEPROM, and so on and so forth. So that is a designated pin. So if some specifications recommend to use this particular pins, then, for example, SCL pins or SDA pins, then it means you need to use PCM, okay, PCM mode. That's what I want to. Okay, and then last week we practiced with LED lights, right? We simply practiced how your Python code running on Raspberry Pi still can control outside device. Okay, outside the device, maybe sensors. One of the sensors that we practiced the last week was LED lights. Okay, so your Python code can control the LED lights in certain way. I know some of you heard of the terminology the physio-cyber security or cyber physical security. Okay, vice versa. Physio-cyber security means cyber is like our computing world, right? Physical security is a physical, not, I mean, historically not connected with the computer, but now it is connected. All the factory plants, all transportations, everything now, right? Even nuclear power plant, they're all now connected to somehow some infrastructure, okay? Maybe to the internet, or maybe some designated backbone. Whatever it is, they are accessed remotely. Then that physical location, physical plant needs physical security. That physical security is controlled by cyber world, cyber equipment, cyber device. Okay. So that is the size of such a security is pretty big. Like electricity power supplies, distribution centers of electric power. That is also now physical cybersecurity issues. There is a physical cybersecurity issues. Gas supply. There is also water supply. There are also physical cybersecurity issues. What we are doing in this class, Raspberry Pi is a cyber world. Sensor, that is a physical world. How your cyber world can control the physical world, like LED light. Okay, this is a small domain. Although we have, I mean, as far as we say, physio cyber security, then that is size-wise, that is big, really big. Okay, sometimes that world covers all over the globe, like airplanes, right? Or nationwide, power supply. So in our practice here, it's a small mini world, micro world. So how my cyber techniques can control external device, which is a physical world. External device, maybe a sensor, right? In our case, rather than take some action into that device, there's some actions, right? What is the actions? LED lights. We turn it on and turn it off. That is the action. Action is taken from actions controlled from my cyber world Python code in running on my Raspberry Pi, right? Today we'll look at a little bit the other way, or both. Take some data from the external world. Okay, so first, what we are going to do, my planning today, so that I need to speed up. Three examples, okay? Sensing distance detection. Distance detection from the one device, okay? And then the temperature and humidity sensors from one device. One device very nicely collect both of those two data. So that's good. And then third example is a motion detector. All right. In the motion detector, which I'm going to do the last part, the motion can be detected. That is the data collection from sensor, right? From physical world to cyber world. When there is a motion, then from cyber world to physical world, which is, I'm going to turn on LED lights. If there is a motion detected, then I'll turn on the LED. Turn on LED means that will be that can be anything, right? You can do anything. Maybe if you are a sniper, if there's some motions of enemies, then automatic shooting, firing, whatever. So everything is possible. If you practice this sensor technologies with the cyber world, like Raspberry Pi coding, then you may think of so many things possible. Okay, so Elon Musk, when he developed the cars, Tesla, probably he understood these issues, so he can do. Oh, I want to make it more intelligent. Okay, my car will be intelligent and powerful. So that is what Tesla cars are now popular. One night, few nights ago, because I practiced with the sensors in order to prepare this class. Maybe this week will be the last week for sensor. Maybe one more week, next week, okay? Next week will be the last week of playing with the sensors. And then we will switch over to iPhone apps. But anyway, so hopefully you have, if you have a MacBook, perfect. If you do not, then in any way, if you can run iOS, that'll be good. If you do not have at all, then there's another way that you can use. You can rent the cloud systems from Apple. I'm going to guide you next week, so you can lease the Apple cloud. Okay. It's not really ideal, but still you can work. So we can talk about that next week. Sensor technology is a micro world. If you develop this, if you scale this up, then this will be the future cybersecurity problems. Okay, that's what I want to tell you. Okay, distance sensors. There's some mathematics related because this is a sonar ultrasonic signals based sensor, and also this is not passive but active. What it means is that it emits, it sends out the signals to an objects, and then receive the reflexive signals from there, and then measure some distance between these two, and that way they can measure this distance, okay, from here to there. Okay, there's some small mathematics, but it is based upon this. For example, the speed of sound is 340 meter per second. You can change this to feet if you like, right? 1 meter is about 3 3 feet, right? There's some floating points values, 3 point something. So you can make this. So I don't know how you can calculate it. You can change it to a centimeter per microsecond if you want. And then distance can be calculated by when you receive this, the elapsed time for, between the time it emits and the time it receives. During that time period, the signal traverses this round trip, right? From here, there, and come back. Round trip, whatever the time elapsed here, that is the time for round trip. So there is a number 2 there. But anyway, during the time, whatever the elapsed time, and this is a second. 1 second, then distance is 340 meter, but actually that is a round travel, round trip. So we need to divide it into 2, right? Half of those. If you see this, then you can clearly understand what it is. That is one thing that we want to work on. For wiring, here in this, the experiment, actually, there's so many things involved, right? Not only coding, not only a Raspberry Pi, but also sensor and sensor specifications. You need to make sure all of those. And then finally, you have to make sure the wiring. You have to wire properly, okay? This distance sensor, this is ultrasonic distance sensor, has 4 pins. Why 4 pins? You can simply think 1 pin for ground, another second pin for power supply, and then two pins left, right? 1 pin that is a signal out, 4th pin receiving the signals. Okay, so the signal needs to be triggered, and signal needs to be received from the echo signal. So trigger and echo signals there. So if you see here, then you can see this is echo, trigger. This is this pin for trigger pins. So you need to read these pins, send out, and then you need to count the time. And then when you receive the signals from echo pins, then that is the ending time points. And then you need to calculate it. And there's some resistance. And this low power, and particularly this ultrasonic, you don't need this, okay? So we're not going to use this. We're not going to use this, okay? So you can practice without, that's fine. You simply connect this, ground, power, and whatever the pin number that you want to use, simply connect it. So you don't need this breadboard, actually. That's what I'm going to show to you, okay? That is a distance detection. This is a code. If you see here code, if you use a board mode, GPIO board, which means there's a circuit board, the numbers inside, right? And then you need to set up the pins, the trigger and echo. Trigger, then you need to signal out. Echo, signal in, right? GPIO dot in. And then output is pin trigger, GPIO low. Low means it is activated. And then waiting for sensor to settle, calculating distance. Okay, oops. Okay, now triggering, and then sleep, trigger, and then stop triggering. And then if there is some echo signals in, so while echo signals, there is no echo signals, right? While there is echo signals, then you calculate the time. This is time difference. This is elapsed time. During that elapsed time, times, I believe this is, yeah, 17,000, right? 17,000 in our the previous slide, but now 17,150. It's not really accurate, right? Anyway, and then we print out the distance. This is what we are going to do. This is a motion detector that we are going to use also. And then 3 pins, ground and power. And this is only the signal that we can receive, okay? So this guy is a PIR, means passive infrared. What it means, it's a living objects. So what we want to detect, what motion that we want to detect. So motion of what? Motion of something living, right? Motion of a truck, fine. Truck is not an organic thing, but still it runs the engine, so there is some heat. Infrared signals can receive some of the temperature, right? It's not a thermal detector, but anyway, some of those. Okay, our humans emit some of the infrared signals out. So it is taken by this sensor. So in this case, I am going to use the LED. So LED is for somehow actuator. When there is a motion, turn on the LED. When there is no motion, turn on. Things like that. So there's an in and out. From cyber to physical, from physical to cyber. That's a both way implemented here. Let me point out to you. So the in, this is for LED. In, this is for motion. Okay. This is for the LED lights. So pin number 3 for, this is also board. Pin number 3 for the LED. Pin number 11, that is to receive motion signals. So we receive here while true, receive from pin number 11. Okay, I. If there is no motion, then I equals 0. If there is a motion, then I equals 1. So when there is a 1, then I can say intruder detected. And then turn on the lights, pin number 3. Okay, and then wait 0.1 second. I'm going back. If there is still motion, then we keep doing this. And when I come back here, if there is no motion, okay, here, if there is no motion, then we turn on. We keep doing this. There's a motion detector. Okay. And this is an IR temperature sensor. In this IR temperature sensor, only what I want to point out here is there is a I2C tool needs to be installed, and then you need to make sure there is a device I2C. Some of the devices needs to be created. And then when you plug this IR temperature, then this needs to be detected. And then there is some detection result there. Only in the case you can use this. Okay. See here, there is the pins. Yeah. The 2 pins here and the other 2 pins there. These 2 pins. Where is it? Pins? Oh, this is for. Yeah, this is for the one for ground, one for power supply, and then the other 2 pins. In this case, yellow and blue. Those 2 pins are plugged this. Okay, so there's SDA signals and SCL signals. Remember that BCM mode designated these 2 signals. If you see that for the pin specifications. Okay. See here, the BCM, then GPIO2 and GPIO3, there's SDA1 and SCL, SDA pin, SDL. So we need to plug that pins here and there. Okay. This is a humidity and temperature sensor. This is what we are going to do also. At the first time, if you want to test, you can test. This is for test. If when test is done, then you can again use that. Let's see if I have that somewhere. Okay, here. Right. So in this case, as you can see here, the 3 pins, okay, 3 pins. These 2 pins, I believe this is power black cable that is ground, and this is only the signals, right? So from one signal, it can send it to us humidity and temperature together. Those 2 values together in tuple formats. So tuple formats will be used. For example, here, Adafruit underscore DHT, a device for humidity and temperature, probably a DHT. Dot read retry, and then you need to specify sensor. So our sensor type DHT11, and then that device is available in this on this GPIO. GPIO is now pin number 4. Okay, in BCM. This guy returns both temperature and humidity. So you can receive humidity, comma, temperature. So first element, the data comes in as a tuple. So 2 elements there. First element is assigned to the first variable here. So first variable that is for humidity. Second variable that is for temperature. Okay, and then if those humidity and temperature are not known, which means values assigned to it, then we print it. I can say temperature. See here, first element, which is a temperature, and second element, number 1 here, that is a humidity. In what format? If it is a floating point, then 0.1, so 1 place of decimal points. So 0.1 F is a floating point, and 0.1 F is also floating point. In this case, we put here C for the Celsius temperature. So percent, there's the humidity. All right. Okay. So three things will be demonstrated. Before I close this PowerPoint slide, I prepared this security issues. As I explained why we do this and what is the scale of application of the techniques that we are doing this. And we can think of for the GPIO pins. Let's say there is a big server, powerful server running. It handles and controls nuclear power plant. So it could be dangerous if there is a malfunction, right? Really, really dangerous if there is an attack. How can we secure it, right? One of the attacks is that you can use the GPIO pins. GPIO pins may be used by someone who is not authorized. Okay, someone who is not authorized. So what should we do? Then this is one possible the preparations for that. Okay, so those who understand the Linux, we run sudo. We handles with the user mode. We add user mode. Okay, we already created the user mode GPIO, for example. I want to add new member into that group, GPIO group. So only someone in that group are authorized to manipulate GPIO pins. If I am not in there, then although I plugged some of the cables, physical cables from this pin to another pins, it's not going to work, right? For example, if there's some inside attackers, so he has some of the privileges, so he can be in my systems, but because he's not in that GPIO, the user member, I'm sorry, you cannot, right? That is one possible ways. Okay, so I'm going to close my lecture. The first experiment, let's do with this. This is a humidity and okay. Let me point out this way. This is a humidity and temperature sensor. Okay. So 3 pins out. If you see there, the pin on top, that is the data. And then in the middle, there is a VCC, which is a power. And the ground, there's a for ground. And also power, there are 2 voltages available in Raspberry Pi. And sensors, also 2 voltages, 5 voltages or 3.3 voltages. So you need to use it very carefully. Where's my glasses? Okay, here. And then we can see in this Raspberry Pi, and I open up that. See here, GPIO 4, that is the PCM pin number 4. It's a PCM. Okay. And then the other one is power supply and ground, right? So here right now, oh, this is clear, right? I think the purple cable is the data, and then black cable that is the power, and white one that is the ground. So come here. I want to plug okay, white and black together. So that PCM pin number 4 and pin number 6 on your right. From top, second and third, that is 5 volts and ground, right? The PCM. So black ones goes to top and like this. So I can make this black and white here. Okay. And then this purple, there's a pin number 4, GPIO pin number 4, so which is a 7. So 4th from top, 1, 2, 3, 4. Yeah. That's what I made, right? If you guys see. Or like this. And I am going to run that. Okay. This one. Python 3. Python 3, and then the program, Python code is hum t while. So I put the while loop. Okay. Put this over. Perfect. Then I'm going to hit enter. Oh, here's an error. What happens? Maybe pin is not properly. Let me see. I think this is okay. Let me check the error. 13 that okay, reason the Raspberry Pi operating systems was not able to run the sensors was because the kernel was modified. Why kernel was modified? The kernel of the operating systems was modified due to the attempt that I tried to set up I2C tools. What is I2C? It is called IIC, integration circuits. Integration circuits needs to be modified if you want to communicate with the analog pins. Remember that Raspberry Pi has 40 pins. All of those 40 pins are for digital signals. But for some sensors needs analog pins. The sensor that I was trying to build on my own was the dust density detection sensor, dust density. It's like an air pollution detection sensor. It needs I2C modifications. Therefore, it affects the kernel systems of the operating system. So what I did was that I rebuilt the Raspberry operating systems. That is something that you can see right now here, okay? So let's try with that. And right now, yeah, this is a little bit of the reconfigurations. Let's see, this is too small, right? Right now, so I'm going to increase the font size. It is 10. So I am going to increase this to maybe 16. Okay. And then I think this is okay. Monospace regular and okay. And size wise, I think I need to increase this. Okay. It is not really well focused. What if I turn on the lights? It's not really helpful, right? Let me see. Trying to adjust. But anyway, hopefully looks dim to me. I'm not sure. Okay, what I am going to do, I'm going to a little bit toward this. Open up the web browser. Okay. Email. Because before I rebuild, I sent out all of the Python code to my emails. So I'm going to download it. I think it is downloaded right now. Okay, push that aside. I think this, why? On this side. On this side, okay. I'm trying to adjust. Okay. All right, go to download ls. So that was downloaded. It was a zip file because I sent out all those files I want to download at once. So I do unzip. They're all unzipped right now here. So I'm going to move those all Python files to I didn't make a directories, so I want to make directory cd mkdir sensors. Okay, so that I have a sensors directory. Move downloads where there is Python files, all of those Python files to sensors. No such files or directories. Wait a minute. Oh, download is a current directory. So I should not like that. I should do simply download and that. Okay. So cd sensors, then I have those all files, right? Okay. So I can now practice it. Before I go further, I need to, one more thing to change, modify here. So go up here, the Raspberry Pi menu, there is a preference and the Raspberry Pi configuration. Okay, come back here. We did that once before, right? In the interface, all disabled right now, right? I didn't set up VNC either, SSH. One, the really important for this sensor data collection was SPI, serial peripheral interface, needs to be enabled. Okay, so these three are enabled. and OK. Probably I think I need to reboot the systems. Okay. So I can do reboot. Okay, open up the terminal and go to sensors. And then I'm going to run humidity. So Python 3 hum t while py. It's not clear, I'm not sure why. Okay, then enter. Right now the module is not available, so we need to install that module. PIP3 install ada underscore DHT. Successfully installed. And I will need to make sure that the wire was properly wired. So move my camera to this. So this is humidity and temperature sensor, 3 pins, and then white ground, black hot lines, power supply that goes into there, and then the purple that goes to the pin number 4 according to BCM. This is pin number 4. Okay, like this. So 4 here. It's not really clear to see, but anyway. Then I redo that. Hit enter. Oh, I'm sorry. Okay, when you have this error messages, okay, we have to fix this. Remember that here, import the BeagleBone black driver as driver. Import error, cannot import name BeagleBone black driver from Adafruit ADT that is in this home PI, local lib, let me click this, Python 3.7 site packages, Adafruit, so on and so forth, okay? So I open up another terminal, okay? So what I did was I go to that place. This is local lib Python 3.7 site package Adafruit underscore DHT, where there is a platform underscore detect.py. First thing that you need to do is, I'm not sure if you can see it, and then I change it into that file. So what I did was, in the VI, I can scroll this down all the way down where there is a, here, in this one, there is no Pi Model 4. This guy is 2708, that is a Raspberry Pi Model 1, Model 2, Model 3, Model 3, 3B Plus, that is a 2837, okay? So there is no 4B. So what I did was that I added 3 more lines here, okay? Exact same ones. If match dot group 1 equals BCM 2711. Let's see, 2711. Clear. Is it enough? Clear. Let's see. Sometimes it is clear, but sometimes it is not. I'll show you the code. Okay, at 2711. Somehow it shows. Okay. BCM 2711. So I added these 3 lines. And then save it. Okay, I saved that. And I come back, CD, and change it to sensors. Come back here. I used the pin number 4. I didn't change anything, but I'm going to run Python 3 and hum t while.py. Okay. So it checks temperature 2.25 Celsius, humidity. So what I am trying to do, if they keep changing, right? So I'm going to move this a little bit. Here is a sensor. So if I exhale, in order to increase the temperature and humidity, see what happens. So temperature and humidity goes up, right? So I'll turn it down. Now it goes down. right? 25, 47% to 24 Celsius. Humidity doesn't go down that fast, but the temperature goes down. Now 22, 23, something like that, okay? So it works if you, only because this was the Model 4, Raspberry Pi Model 4, in your that local lib and Python directory. If you go there, then there's a platform detect.py files. That file does not have the Model 4 specifications. Okay, it is called the BCM 2711. All right. Thank you. Okay, now I'm going to show to you how this distance sensor works. So I have the ultrasonic distance sensor here. There are 4 pins. Okay. On your left, there is a power, trigger, echo, and ground. So here in this wiring, these two are the power and ground. This is a board, okay? And then trigger goes to the 4th pin, which is pin number 7, and then pin number 11, that is for echo. Okay, it's exactly the same as shown on your slide. And then let me try to run this. Okay, ls. So Python 3 dist while.py. Okay, enter. And then distance is, I am moving this, so you can see when I point this to different objects, so that you have different distance. Okay, see here, distance keep changing. When I move this, I turn around this. Okay, little further and little shorter objects. Wherever there is objects, and then there is a reflect. The signal reflects. Echo signals comes in, so that it can detect a different distance. Okay, so you can do Control C to stop it. Okay. Now we can test the motion detection. Okay, so motion detection sensor. In this case, 2 sensors collaborate together. Okay, I think this is a very good project that you can practice. Okay, I explained that on the slide. on your motion sensor, well, there are three cables. Okay, three cables. If you see inside very clearly, it says G4 ground. Let's see. Yeah, GVS inside. Between this sensor and then this black cable there. If you see it clearly, I mean very carefully, there is a G for ground, B for power, and S for signals. Okay, that signal goes to on this code. Signal goes here, 11, pin number 11 on this board. And then I am going to set up LED lights. This is for output. This is coming in, right? From physical to cyber through the motion detection. And then from cyber to physical, that is the LED lights. That's the lights itself goes into the pin number 3. And then there is a ground wiring as well. So I am going to the wiring here. The black is, and by the way, this is a board, okay? Board, GPIO board mode. So this is 5 volt here, and then white one is ground here. Ground, which is third from the right top. 1, 2, 3. Third one is ground, and the second one is black, which is the power. And then another one here that goes to, I think, 11. 11, if you count from 11 is on your left column, right? Left column. So 11 is 1, 2, so 1, 3, 5, 7, 9, 11. So 1, 3, 5, 7, 11. One, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah. So this goes to, this is 11. I need to make sure that is 11. So 1, 1, 3, 5, 7, 9, 11. So 11. So this is okay. And then I have LED lights. LED light goes to 3. That is 3, 1, 3. So 1, 3, that is 3. And then this goes to the ground. I think I have another ground. Ground is number 4. Here the ground. Right? That is 1, 3, 5, 7. 1, 3, 5, 7. No, 9. One after that. One after that. That is the ground. Pin number 9 is ground. Oh, already. Circuit was made. Something that it is not really yet detected, right? So I can do Python 3. Okay. Hit enter. It goes so fast. No intrusion, intrusion detected, right? I am moving now. This is, right. So when it twisted like this to me, then the object was detected, right? So intrusion, no intrusion and things like that, that is detected. Okay. When I move this, okay. When there's a detection, then lights on and off, right? Somebody in, then lights on, no one's, then off. Okay, so it works like that. All right, so I'm going to stop it. Okay.